It's another day, welcome back. Today we'll be discussing exactly how to make functions work whenever we take in some input parameters. From last time, you might remember that our function definition looks like the following. We have a type, name, followed by two empty parentheses, and then a curly braces. Basically what this equivalates to is we end up producing some sort of a box that does whatever the body of the function is doing over here, and it produces an output of a specific type. And for convenience, we like to provide this box with a name. The thing we haven't discussed is how do we pass things into this box so this box can use it. For example, the formula for an area of a circle, 2 times pi times r. This formula is only really useful whenever r can vary. If r always was a fixed value, let's say the number 1, then the formula for an area of a circle wouldn't really make sense. So if we wanted to write a function that could produce the area of a circle, we might end up writing something like this. So first of all, because we know that pi is going to be a decimal number, let's stick to using floats. The formula we're writing is an area of a circle. And the parameter that's going to vary is also a float, and it is a radius. And the body of this function is going to tell me to return 2 times pi times radius. But because I additionally need to know what pi is, I'm going to say float pi equals 3.14. So now I've written a function that will produce a number out that's a float. The name of the function is area of a circle, and the only parameter it's going to take in is a radius, which is also a float. So this equivalates to me effectively having a box that is going to do the body of my function, but the only output is a float, and the number coming in is also a float. So this function that I've called area of a circle transforms one number into a different number. The first number happens to be named radius, and I know conceptually, because this function is named area of circle, that the output type really indicates that the number I'm getting out represents the area of a circle. Let's try to think of a different box. Now, what about the area of a rectangle? The area of a rectangle effectively can be defined as the following. Area of rect. We know we want two numbers. One of those numbers is going to be a height. The second number is going to be a width. And the output is going to be another number. So the syntax for describing a unit of work that will do the following will end up looking like this. So the output is a float, so we always write that first. The name is called area of rect. And now the inputs are going to be, the first one will be a float named height. The second one will be a float named width. And in the curly braces, I can describe the body of my code to say return height times width. So now I have written a function that is taking in two inputs, height and width, and then returning to me one output, which is the area of the rectangle. Now, if you might notice, there are a couple of things. One, between these two, the way I've enumerated multiple parameters is by using a comma. So all of my inputs are labeled within these parentheses. However, I have used commas to separate between every input. Additionally, every input has two parts to it. Every input will always have a type and a name. Now notice Inputs don't have values because the values should be passed in by whatever is going to be using that function. So all input parameters have to have are types and names. And effectively what you end up doing over here is you're making two variables that are used in this function and only in this function. So you can think of it like you're just creating two variables of a type as you described and the name as whatever you've written. And additionally, these variables are only usable within the scope of the function. That means once you cross out the function, you also cross out these variables. Secondarily, you might have some challenges deciding what is an input parameter, what is not an input parameter. You might have noticed that I chose to use pi as a variable inside of my function. So because the function body is just a scope of code, you can write any sort of code you'd like in there. You can call other functions, you can create variables, you can use if statements. Anytime I have a variable that really won't change regardless of the input, so for example the value of pi will always be the same, I can just make a variable inside of my functions. I don't want it to be an input parameter because I don't want someone accidentally passing in the number 500,000 for pi. And lastly, with regards to the types of input parameters, there's no requirement to match the output of the function. There's no requirement to match the other types in the variable. You're allowed to have as many input parameters as you'd like in a function, and you can have as many types as you'd like. That means you can combine a float and also have a boolean and also have a character and an integer. Nothing prevents you from doing that. All that's important is when you make an input parameter, be sure to use the type carefully based on what your purpose is. Let's go over onto the REPL and do some practice to see what this code reacts and how it might apply to our memory table. So, the first thing I'd like to do is I'd like to make my function area of circle. The function will take in a float that is a radius, and it will return to me 2 times pi times radius. And of course, because I don't have a pi variable yet, I need to make a float. Pi equals 3.14. Let's make another function that's called float get user input, and then return input. So now let's talk a little bit more about how we're going to end up using these functions. So we know how to use our first function. We can say float r is equal to get user input. But then if we want the area of the circle, we want to somehow use the area of a circle function to produce this float for us. So just like before, and we're going to pass in whatever variable's value we want to substitute in for the radius variable here. So in this case, I want r, the value of r, to be used as the value of radius. And lastly, I can say std_cout radius r area return 0. Let's go ahead and run this code and see what happens. So the first thing it's asking me to do is enter a number, and this looks just like here. So let's say I gave it a radius of 10. Now, even though my code is doing something, there's a bug here. My code is taking in a number, it is running this function, and it's even going through and executing all of my lines. However, the bug in this code is not a bug like you've been used to seeing. The bug here is actually a functional bug. Some of you may have noticed this earlier. Area of a circle is actually not 2 pi r. The circumference of the circle is 2 pi r. So if I actually wanted to compute the area of a circle, it's actually pi times radius, pi r squared. So now if I run my code and I type in the number 10, I should notice that the area I'm getting is about 314, given a radius of 10. So what is this code doing? The best way to understand what this code is doing is going to be our memory table. So let's slide on over to our memory table, and then we can evaluate exactly what's happening in this code line by line by line. So as always, we're going to start from the main function. Our function name is going to be called main. The type of this function is an integer. It has no variable name. And the value of this function is a question mark because we haven't yet gotten a value for our main. And the size is going to be 4 because an integer is 4 bytes. Then we're going to enter a new scope on line 15. And on line 16, the first thing we're going to do is we're going to make a variable of type float. The name of this variable will be called r. The value of this variable is going to be coming from us calling a function. So before we go ahead and dive into the function, let's just fill in the size as 4. And the value of this variable is going to come from calling the function getUserInput. So we know we're going to dive into a function called getUserInput. The getUserInput function, because we're just calling with empty parentheses, takes in no inputs. So we're going to go up and find the getUserInput function, which is described on line 3. Line 3 tells us that the getUserInput function takes in a float as its type, or has a float as its type. It has no name, and the value of the function so far is unknown. And the size is going to be 4 because floats are also size of 4. Line 3 then tells us we're going to enter a scope. Line 4 informs us that we're going to print out enter a number onto the console. Fantastic. Line 5 asks us to make a variable and name it input. Its value is a question mark as of now, and the size is going to be a 4. Line 6 asks us to take a number in from the console and set that as the value of the variable input. So let's go ahead and do that. I entered in the number 10, so I'll use 10. And then we're going to use the return keyword to get the value of the variable input, set that as the value of my function, and then cross everything out up until the scope of that function. And now I'm going to go ahead and go back to the line from where I called getUserInput, and that was line 16. And the last part of line 16 is to take the value of the variable from my function and set that as the value of the variable r. And right before I move to the new line, I'm going to go ahead and cross out my function call as I'm done with it. Now line 17 is doing something slightly different than before. We're using a function with a parameter. So the first thing line 17 reminds me to do is to make a variable of type float called area. The size is going to be 4 because it's a float type. And the area of a circle is I'm going to set the value of the variable area by calling the area of a circle function. So let's go ahead and do that. And in the area of circle function, I know I'm going to be taking in a parameter this time. So before I do anything, I'm going to go ahead and find the definition of the area of circle function. That happens above on line 10. The type of an area of circle function is going to be a float. It doesn't have a name. It doesn't have a variable name because it is not one. And the value so far is a question mark. And the size is going to be a 4 as well. But it additionally has a parameter. The parameter is of type float. The parameter's name is radius. The size is going to be 4 because it's a float. But the value comes from wherever I called the area of a circle function. So I'll go back to where I called it, it tells me that I'm going to use the value of the variable r. So when I go and find the variable r, I'm going to take its value, which happens to be 10, and set that as the value of my parameter, which is radius. And then I'm going to go ahead and continue the rest of my function definition, which then tells me to make a new scope on line 10. Line 11 asks me to make a new variable called pi of type float. The value of this is 3.14, and the size is going to be 4 as it's a float. And then it asks me to return the value of pi times radius times radius. Now radius times radius will be 10, times pi will be 314. So it's asking me to set the value of 314 as my area of circle function. And then it's asking me to go ahead and cross out everything. Notice I have crossed out not just the scope, but everything all the way up until the line that defines only the function name. That's because once I've returned, the input variables are no longer useful. All the variables within the scope of the function are no longer useful. They are all out of scope. Their lifetime has ended. The only thing that will be relevant at this point is going to be the return value that is coming out of your function. So when I go back to where I called area of a circle from, I'll go back to line 17. Line 17 reminds me that the reason I call this function is to set the value of my area of circle, of my area variable. So I'm going to go ahead and set the value of my area variable to 314. And then I'll go ahead and finish crossing off the rest of the function. And then line 18 asks me to print out to the console the word radius, followed by the value of whatever is in the r variable, which is the number 10, followed by the word area, followed by whatever is the value of the area variable, which is 314. And then lastly, on line 19, I'm asked to return out from the main function. So it's asking me to return 0. So I'll update the value of my main function to be a value 0. Then I'll go ahead and cross out everything else that is all the way up until the most recent scope. And then because this is the main function, I can go ahead and look at the value of my main function, which is 0, and know that I successfully exited the program. And that's it. We just learned how to use functions with input parameters. It's not any more complicated than per se using functions and no parameters. However, it does enable us to write our code in a much, much cleaner way. Now, before I let you go, I want to describe to you a few key principles that are going to help you write better code. 1. Functions are purely a way of organizing code. They shouldn't really change what your intention for the program is. They should immensely increase the readability of your code. You can think of it like having a run-on sentence in English. It's very hard to follow the thought process of an author if there are no periods, no breaks, and everything just flows all as one big chunk of text. You can think of the body of any function, including the main function, as just one big chunk of text. The more things you have you're expecting one scope of code to do, the more complicated it's going to end up being. Number 2, naming, naming, naming. Just like I had emphasized when we were doing variables, naming your variables consistently is super important. It's just as important when naming your functions. I personally like to name my functions with upper camel case. What that means is every function is going to have every single word with an uppercase letter. No underscores, no spaces as per usual, just an uppercase letter for every single word. Now, with my variables, I like to use underscores. Now, the benefit of naming my variables consistently and then naming my functions consistently in a different way is whenever I look at something, it immediately signals to me what that thing is. If I just see the word area of circle with upper camel case, then I know I'm reading a function name. If I see area of circle all lowercase with underscores, I know I'm reading a variable name. Now, these small things might not seem like much, but when you're reading lines of code, when you're reading hundreds and thousands of lines of code, These small things are just going to enhance your ability to comprehend and internalize larger chunks of code. And number 3, while a function can have any number of inputs, a function can only have one output. There are more complicated concepts that are going to allow us to have functions with more than one output, kind of. But for now, I'd like you to frame problems as questions that only produce one output. If you find yourself getting to a point where it only makes natural sense to use a function that perhaps can produce two outputs, you're going to have to just not use a function in that chunk of code for now. We will get to it, but for now, we will only be focusing on functions that produce one output. And that's it. That's the fundamentals of functions. With this, you're ready to go off and start using functions in your own code. If you see some sort of pattern where you're passing in some sense of input and some amount of outputs, see if you can squeeze in a function in there. The exercises this time are again going to be focused on readability and comprehension. The area of a rectangle problem specifically is going to be a memory table you'll have to walk through. And we'll be using this to make our calculator significantly easier to read. I'm so excited to see all the results you'll be coming up with. I hope you have a good time, and until next time, goodbye.